And there you go. Just a heads up. 2 weeks from today, on April 2nd, there won't be any class. I'll find a YouTube tutorial out there, and that'll be the assignment to recreate whatever you see in that video. My son's getting operated on that day, so I won't be here. And I'll mention this in all my classes, but on Wednesday during the day, then I'll do the same thing. I'll have some kind of YouTube video out there for tutorial for the programming topics. The afternoon and evening, I'm pretty sure I'll be available for them, broadcasting from home. My son's having a surgery on the 2nd, and assuming no complications, he'll be coming home the 3rd. But I know what that usually means. You don't get out first thing in the morning. It's like late in the afternoon. So 4 o'clock, one might be questionable, but 7 o'clock I should be able to broadcast from home. But if not, then I'll put something out there for those students in those classes. I'll try to remember to mention that every time between now and the 2nd, so nobody's caught off guard. Okay, so I'm going to bring up Visual Studio. And how you can bring up Visual Studio Direct is you come down here and you just start typing Visual Studio. And there's our Visual Studio 2017. We're going to do some reviewing today. And this is in preparation for a test that I already put out there. It is a time test. You get 80 minutes for it. There's 3 questions. They're programming questions. And they'll be based on some of the topics that we'll be going over today. Some of these topics you've seen. Some of them you may feel very comfortable with. It'll be easy test for you. This is part of our accreditation. We have to have some kind of measure of how people are doing in the programs. And so there are 3 completely programming-based questions. You'll write your program. You can do it directly in Visual Studio, like you're going to see here. You could, if you want to, do it in Unity/Visual Studio, where you take your answer and you plug it into the text box or label over in Unity. You could even do it in the console, where you do your, I think it's debug.console, console.debug. I don't remember the exact syntax. Debug.log, one of those, no, debug.log, I think it was. You could print your results there. What you're going to turn in is you edit copy your code, paste it in there. You're not zipping up anything. You just edit copying your code, pasting it in there, and also the answer. Some of these will, 2 of them, will be looking for a numerical answer. So you put down the number answer also. Now you have to put your code. You can't just put the number down. Okay. Like I say, this will probably be boring for some, but what I found last semester, I do this every semester because required to. I did it a little bit later in the semester last time, but I want to have time to compile all the results and get it sent into the program outcomes people, so I don't have to do it last minute since we're in the spring semester. But what I found is that those who were taking the game development classes and the 3D computer animation classes, although we covered those, they were kind of weak in those areas, because really with what we've done in Unity, we haven't had to use any while loops, any for loops, which is 2 out of the 3 questions. I did cover those at the very beginning for those classes last semester, but then didn't really review before getting the test. And scores are low. So I'm going to review those concepts. This is not going to be what the test is based upon. It's a different programming project, but it's still based upon the three constructs: your if else, your for, and your while. If you're taking another programming class, you're probably pretty comfortable with this. And you'll be tortured in those programming classes too. The only one I think this semester I'm teaching that isn't, or the only two that aren't programming based, is the Network Plus and the Introduction to Computer Forensics. They won't have that test, because obviously you can't. Okay, if I do a File New and choose Project, some of you have never perhaps seen this. Some of you have. We've been going into the creating a console app fairly often. So I'll go into console app here. I think it takes so long to create a console app. There it goes. Okay. So this comes up. A little bit different than what we're seeing with Unity when it created the classes and so forth. But still the same principle. We have our class. It's a program here. And then our static void main. This is, if I do an enter here, this is where the majority of our code is going to go. So it goes within the main section. To print out results, you can use console.writeLine, and I'll just do a simple hello world. Now, it has to be uppercase C, has to be uppercase W, uppercase L, so it's all case sensitive. So you have to type it exactly as you see it there. Now, to run it, before we would attach to Unity and so forth. To run it directly from here, you choose debug, and you choose to start without debugging. So Control F5. And you see it says hello world. So print that out. Hi. Yeah, but if you're here to work on the shelves, you feel free.
Where do you want to go?
In the room. I'll be right back, Kyle.
All right.
That far wall over there. The only thing has to go in there is that laptop card. So the rest of it, I can put on shelves, move out of your way,
So do you want the big? Because there's more than one size of shelf. Do you want the deep shelving?
It'll be for computer equipment.
So in the yes.
Is that you think the deep would be best for computer? Monitors and so forth?
Well, we're gonna do showers and stuff.
Yeah, see the wide like that.
Like this.
Like that to do that. That's not real wide.
thanks.
Getting my shells. I'm excited. I can finally organize a room. So I'm happy. Okay. Anyway, this ran. If you just do the start here, it'll display it, but then I think go away. It does. So again, we want to do the debug. Start without debugging. Now, pretty much all the coding you've seen has been in C#, so there's really nothing new there. You declare your variables, int, sum, that's declaring an integer, just like before, double, amount, so that's a number with decimal places. We use float in quite a few places. And you can use float in this if you want. I expect most things that you'll work with will probably be fine to be either an integer or a double. To declare a string, you do a string like that. Now, if we want to get input from the user, we can use console readline. For example, if I said, you see all the stuff in there? Yeah, I'm excited. I'm going to be able to move all that out of there. If we said input amount, then you can say S is equal to console.readline. Like that. And then that'll read that in. Console readline brings it in as a string and assigns it to S, which is a string. Now, at this point, this is going to be a string, and we want to convert it to a number. So let's say I did have a double. And maybe I'll say this is a grade. So they're inputting the amount they got on the test. Now here I'll say grade is equal to double dot parse. And then we put in what we're converting. So this will take that string, S, and it'll try to convert it to a double. Now, if it's not actually a double, then it may give you an error. We haven't really looked at exception handling for this. We're going to look at that in the C# programming class, actually. We don't really put a whole lot of that into Unity because it's so locked down. So it's hard to input a bad value if all you're doing is pressing a key. Okay, now if I run this, actually I better print it first. Console.writeLine will print any type of object. This is what's called overloaded. That's where you can call it different ways. You can just call it that way, just as current line terminator. Or if we do the drop down here, these are all the different things you can pass in. And even more than that, it gets here to this object value, and that pretty well just opens up the world when you say it can be any object. But what I want to print is I want to print the grade. So let's just see what that comes out as. So I do a debug, start without debugging. says input amount. If I put in 32, comes back and just says 32. So nothing too exciting. Part of coming out of any programming class is you should know the basic constructs. And that's really the purpose of all the programming-based classes, is that you do learn those. I've really struggled with trying to figure out how in Unity to incorporate more of the for and the while. You see the if a lot, but the for and while, it's a little bit more challenging on how to incorporate that in, because it's built in. It's constantly doing a while, while the game's still running, while the game hasn't terminated. It's going through and doing that update over and over. So in a particular Unity game, it may have a total of 20 while loops that are sitting there running based upon those updates that we've seen. But you're not controlling it directly. Now this is going to show us our if-else type relationship. And again, we've seen this before. This shouldn't be too big of a surprise for anybody programming Unity. I'm going to do an if. I'm not sure if we compared a number directly, or it was always based upon something we pulled out of the transform. But I'm going to say if grade is greater than or equal to 90, then I'll do a beginning curly bracket, and automatically puts closing curly bracket, and I'll do a console.writeLine. You got an A. Now, the different Boolean operators we can use there. There's greater than. There's greater than or equal to. There's less than. There's less than or equal to. There's equal to. Most programming languages require you to put two equals. There's once in a blue moon, you run across a programming language where it allows you to put a single equals. But a single equals in programming is an assignment operator. And it'll either be an exclamation equal or less than greater than. Programming languages vary on those. But those are the most common ones we run across. The greater than or equal to is checking to see if it's equal to 90 or above. If it is, then this returns a true or false. If it's true, it does this line of code. If it's not true, it comes down here. And I can do an else and put another if. If grade is greater than or equal to 80. Technically, since we have one line of code, we don't need to put those braces there. Doesn't hurt anything. You got a B. And if I continue down, else if grade is greater than or equal to 70, console.writeLine, you got a C. I don't think we had too many nested if-else statements in Unity, if I remember right. But you can do this. And then console.writeLine, you got a D. And if it's none of the above, then I'm going to have simply an else statement that will run if none of the above is true. And this will say console.writeLine, you got an F. Well, first let's take a look at it and see if it works. And then if it works, we'll talk more about the details behind it. So do debug, start without debugging. And put them out, say I got 92 on test, says you got an A. If I run it again, say I got 35, it says you got an F. Now up here, after we bring in grade and we change it to a double and assign it here, then when this check occurs, if our grade is 92, for example, comes down, it does this here. Checks. Is 92 greater than or equal to 90? It is. So this returns true. And it does this line of code. And after it does that line of code, it drops down to the very end right here. And if I'd had other lines of code here, it would be running those. So it doesn't do all the rest of these. If I had a 73, it would plug 73 in here and say, is 73 greater than or equal to 90? No, it isn't. It's false. So it comes down to this next else. And says if checks to see if 73 is greater than or equal to 80. It's not. That's false. Comes down here. Check to see if a grade, which is 73, is greater than or equal to 70. Then that's true. So it would print this, and then it would kick down here to the end of the FL structure. Now again, the program that I'm asking you to write that uses an if-else, after you get this done, you just edit, copy your code. If you want to copy everything on here, that's fine. If you want to copy everything, I know I can look at it and decipher the piece that's pertinent. Now this one will ask you to print a result. And so you just print on your test what your result would be. Does that make sense, Kyle?
Pretty much.
Okay. Now let's take a look at the for loop now. Okay, so I'm back here to our main. And this is showing an example of a for loop. Now a for loop, for int, and some programming languages you have to declare it outside of the for loop, and I don't remember, to be honest, in C#. But we set it equal to 0. We continue while x is less than a value, and x plus plus. Looks like it didn't mind me declaring it in there. There's one programming language I'm teaching this semester that doesn't like it declared right here. I think it's C, actually, which is weird because these are all based upon C. Now, if I just do a console.write line and print x. Now, if I run this, you see it prints 0 to 19. 0 to 19. Well, it starts at 0 because that's what I initialize it to. This first part is your initialization. So this only occurs one time. First goes in the for loop, it initializes it to 0. This is checking, when do I continue? Well, you continue while x is less than 20. And then this right here is what do you change x by for each iteration of your loop. And the x plus plus there means you're increasing x by 1. Now, you don't have to increase it by 1. You could actually put an assignment statement here. X is equal to x plus 5. And what this will do is it'll increase it by 5s. So if I run that, see, it goes from 0, 5, 10, 15. My next one would be 20, which is not less than 20. Now, you can do the same operators here. Less than, less or equal to, greater than or equal to. I'm so used to starting at 0 and going up to a larger number that it really throws me sometimes go backwards. But you could start at 20 and continue while x is greater than 0. That'd be 1. Yeah. And over here, you could have x is equal to x equals x minus 1. So this should start at 20, and this is decreasing it, so it should go 20, 19, 18, 17, and continue while x is greater than 0. And so we got 20, it goes down to 1. Okay. You have to be careful on a for loop. Typically, a for loop is pretty solid. It's hard to mess it up and create an infinite loop, but you can. If I had, instead of x is greater than 0 here, I'll continue while x is less than 21. Now let's put 20 in, because I'm not really sure when it does the check. This will tell us. Didn't print anything. So it initialized it and immediately did the check before it ran through a loop. So, and 20 is not less than 20, so that's false. So it didn't do the for loop at all. So it looks like it does this, checks here, runs your code, and then decreases it.
So C# reads from top left to bottom right then?
Top left to bottom, yes. So to get it to go to an infinite loop, I put x is less than 21, and now it should go through. I was actually running that, wondering that the other day, and you see it goes on forever. Because I was trying to remember which sequence it does that in. But yeah, it does this at the very beginning, and then does this before it does this check here before it does the loop, and then does this after it does the loop. Okay. Let's take a look at actually finding I guess factorial. So let's find 5 factorial. We might have looked at in other classes, but 5 factorial is equal to 1 times 2 times 3 times 4 times 5. Mathematics-wise, it always goes from 1 up to whatever number you input. So 5 times 4 is 20, times 3 is 60, times 2 is 120. So our answer should give us 120. Now, looking at what your loop goes from helps you set it up. So this has to go from 1 to 5. So I can start that at 1. And I could put an equals on here. So it'll go from 1 to 5. And then here I could just simply do my plus plus, or you could do x equals x plus 1. It's always a good idea on these, before you do anything, is just print out your results and see if it's what you expect. See if this prints 1 through 5. So if I run that, and it printed 1 through 5. Well, I need to have a variable so I can multiply them together. So I'll create a variable up here called int fact. And normally when we're accumulating, summing, or subtracting, you set it equal to 0. When you're multiplying, it's always 1. I'm trying to think divide, but I'm not sure if I've ever divided a lot. But fact is equal to 1. So then down here, this is an integer, and this is an integer. Make sure that you don't mix the 2 different types. Sometimes it'll let you, but sometimes it'll say, hey, this is a double, this is an integer, this is a float, this is an integer. So if you have troubles on the test, look for that. And here, I know that's working, so I can get rid of my console write line. I'll say fact is equal to fact times x. Now, if I wanted to print out the value of fact, I could do the console.write line and print fact. And we'll see what it builds as. So first time through, fact is equal to 1. X is equal to 1. 1 times 1 is 1, so fact should be 1. Next time through, the x increases by 1, so it's 2. So I got my old value of fact, which is 1, times x, which is 2. So 1 times 2 is 2, and fact will be equal to 2. Then x is equal to 3, so you got your old value of fact, which is 2, times 3, which is 6, and so on. And I see it goes up to 120. You can have this in here to test it, but all you really need to print your answer is here at the end, outside of the for loop. You can print that value there. Now, we're showing this the console write line here, and we're seeing the results of it and so forth. You can do that same thing in Unity. So we extend this a little bit to what we've been looking at with Unity. If you're trying to figure out what's going wrong with your program, doing that, it's not console dot, it's debug.log, or I wish I could remember that. But that does the same thing. Prints it to the console of Unity, so you can see your results. Very handy if you're trying to figure out why something's not working. Now, sometimes you can have too much of the data come through, and debugging then helps on that. Okay, so if I run it one last time, I see it gives me 120. How's that on the for loop? Do you feel okay on that?
Yeah, that makes sense.
Okay. Well, let me pick an example for a while loop. And I'm actually going to do the factorial first, and then I'll do a different example. Now, a while loop is different. All it has here is the check. So while x is less than or equal to 5. Just as with the for loop, make sure you do not put a semicolon at the end here. We didn't have a semicolon at the end of the for. The line actually had the for on it, and we can't have a semicolon here. That's a common mistake people have in programming. Now this right here is our check. This is when it's going to continue. So this will continue while x is less than or equal to 5. And I chose x because that's what we had in our previous example. Well, our initialization does not go inside the while loop here. So you have to have it separate. So I'll say while x, or int x is equal to 1. So that's our initialization. This is our check. And then we have to have our increase be down here in our while loop. So down here, I'm going to say x is equal to x plus 1. Or you could type x plus plus, semicolon. Now again, I'm going to do a console write line. Just to print the values of x to see if I'm right, see if I'm on target. This doesn't work obviously if you have 10,000 entries and you're trying to look at every one of the numbers. But even if you have 10,000, you see the pattern when it starts scrolling through. And I see it goes from 1 to 5. So that part appears to be working. And just like before, we're going to say fact is equal to fact times x. Same rationale. I could put a console write line here, and that is good for debugging. But since it's pretty much the same code, I won't do that. Get that on the right line. There it goes. I do debug, start without debugging. 6. Guess I should have, what did I do wrong? I increase x each time. Fact is equal to fact times x. 1 times 1. Oh. Helps actually print the right result. $120. There we go. So that's our program for that. Now you could have the user input numbers in, and then add them together. So for example, I want to calculate the average. Well, for my average, I need my sum, and I'm going to make them double. If you know you're going to have or you potentially could have decimals, go ahead and make them double. So I say double sum, and I'll initialize it to 0 because we don't get any numbers yet. Average, well, that's going to be a double. I don't need to set equal to a value because it's not equal to anything yet. Now let's actually create one called count. We're going to mix the double and int and see how it works in this case. Sometimes it works just fine. Sometimes it'll tell you that you can't do that. Okay, so we're going to maybe use some kind of trigger for our while loop to kick out, to say, okay, we're done. So maybe we'll continue until the user inputs a negative number. Okay, so like a -1, for example. So I can say console dot write line input a number, input number -1 to quit. Then, before I even go into the while loop, I want to read in the first number. There's different ways you can do this. I'm going to say if I'm trying to think what my number is. Do I not have a number? I guess I don't. I got sum, I got average, I got count, but I don't actually have the number they're inputting. So I'll just call it num. So I'll say num is equal to, and I need to convert it. It'll come as a string if I do a console.readline. So I need to say double dot parse, and I'm going to have console.readline. Now that should convert num to a, or should convert their input to a double and assign it to num. So here I want to check while num is greater than or equal to 0. I'm going to continue. So if they put a negative number, I won't continue. Now I'll probably get weird results if they put a -1 to begin with, but I'm on test. I'm not going to grade you based upon error checking. So if you get the right result and use a while loop or for loop as in the previous one, I'm happy. Okay, so down here then, I'm going to say sum is equal to sum plus number. And count is equal to count plus 1. Or you could do count plus plus. Now at this point I'm in my while loop. I want to get my next number. So I can copy this right here and paste it right here. So this should prompt them for the next number and convert it. And then that's now sitting in num. So then it'll come back up here. Now here at the end then, I want to calculate my average. So average is going to equal to sum divided by count. And then I'll do a console.writeLine average. This is called a sentinel controlled loop where you're controlling it by some kind of flag they input. Now -1 is really kind of a holdover from programming languages didn't have the same capabilities as C#. A better one probably is to use yes or to no to no more numbers. And then you bring it into a string and you check to see if it's no. If it's no, you're done. If it's not no, then you convert it to a double and assign it to num. Well, let's see if I'm even close. I don't always get programs right the first time. For 2, I'm 4 in, and I'm going to stop there because that's an easy one. 2 plus 4 is 6. Divide by 2 would give me 3. So I put -1 in, and it gives me 3. Let's try decimals. Debug, start without debugging. Let me see, 5.1, 7.2, 3.1, -1. That's going to give us something like 15, 20, 20, 20.4. 20.4 divided by 3 is 6 point something, I think. 6.8. Never would expect that to come out with that few decimal places, but I guess that makes sense, though. If you're dividing and you got one decimal place. But that's showing a while loop where you're taking user input and doing something with it, and it can branching through. Again, what I would do is I would edit copy this code, paste it into the little box. It'll be an essay type question, so you paste it in the little box, and then you paste your answer down below it. Is there any questions on the while loop?
No.
Okay. Well, there's one last thing I want to show you here that might help you. I don't think I've showed this in C#. Maybe I have, so you might have seen this. But over here on this side, there's this gray area. And I can click over in this gray area and it puts a red circle.
Isn't that the debug stuff?
Right. Did we look at that in C#?
Yes.
Oh, okay. So I won't.
I think it was 3 class periods that we've looked at it in C#.
Oh, okay. So I'll just mention real briefly then, since we've talked about that. That's where you can click the start here. And when you put in a number, it kicks out here, and you put your mouse over that, and you can see the value. And to go through it line by line, there's this little button here, step into F11. and that'll go through it line by line. Even more, it'll tell you how many milliseconds have elapsed. So if you got something wrong with it, then you can see. And you see down here, your variables will appear. Okay, to stop debugging, click this square right here, and you click this over here to shut that off. Is there any questions on the? Oh, go ahead.
You want the bottom shelf and how many top shelves? Because you don't want to put a lot of weight on the top.
You don't want to put a lot of weight on top?
Right.
Um.
So we're not attaching to the wall because those are just metal studs and it won't matter what you already attach it to because it will rip it out.
Oh, okay. So what kind of weight would you want to put on top? Like monitors or?
Monitors across the inside.
Okay. Then as much as you can at the bottom, have a height, where it'll fit any of those computers you sit there. It's either the height for those. And then the top, I'll just put monitors on, so about that high is. Now the test is timed. I think it's 80 minutes you got, so an hour and 20 minutes. Don't start it now because I guess you could. I'm going to give kind of the same spiel in the virtual reality programming class. I'll try to work different problems so that if you've seen this, then be something a little bit more challenging. I'll look for something besides using this. There's some interesting ones on computing pi. I'll see if I can find one before that class starts on that. But again, they're essay based. Each one's worth 60 points. You copy your code, paste it in there, copy your answer, go on to the next question. I think it shows them one at a time. And then when you're done, you click it. If you don't finish in 80 minutes time, it automatically submits it for you. So make sure you have your code in there and so forth. Questions on the test?
No.
Okay. Well, that's all we're going to cover today because it is the test day type of deal. Next time we'll get back into Unity and back to the more fun parts of the course. So, I'll go ahead and stop the recording there.